Hi guys, today you're going to learn about molecular polarity. So here are our options. In the word polarity, you see the word polar. Okay, so we're going to talk about whether molecules are polar or nonpolar, and here's what that means. A polar molecule is where the electrons are shared unequally between the atoms. And so when they're not shared equally, you have a positive end and a negative end. The electrons kind of get pulled in one way. So a good way to think about this is pretend I have a circle. If I don't share it equally, then I break off a little piece like that. Okay, so I don't have two equal halves. That's what polar looks like. Not sharing, which is not very nice. Somebody got a bigger piece. Now, if it's a nonpolar molecule, then the electrons are shared equally between the atoms. So again, if I think about that cookie, and if I break it perfectly down the middle, each piece is the same size. That's a nicer way to share because no one's getting a bigger piece. The way that you're going to figure out whether something is polar or nonpolar is it all depends on those Vesper shapes. So remember linear, tetrahedral, trigonal planar, trigonal pyramidal, and bent. The reason that it's so important that you know those is because that's how you're going to figure out polar or nonpolar. So if you can't figure out those shapes, you need to stop right now and go back to that video. Okay? Once we know our shapes, that's how we're going to figure this out. If a molecule is linear, meaning the center atom has one or two atoms and there's no extra pairs of electrons, then your molecule will be polar if the outer atoms are different, okay? Which means it will be nonpolar if they're the same. So let's do two examples of what that will look like. So let's draw CO2, carbon in the middle, 4 electrons, oxygen on each side, 6. Remember that comes from the group number. Okay. Connect the unpaired electrons. So this center atom has 2 other atoms stuck to it. There's 1, there's 2. And see how there are no extra dots here? That's what makes this molecule linear. So if I draw a nice neat final copy, draw my double bonds, put my extra pairs on, that's a nice linear molecule. Okay. Now, the outer atoms are the O's. So here and here. If the outer atoms are the same, then you can identify the molecule as nonpolar. Everything is being shared equally between those C's and those O's. Now let's look at another possibility. Let's draw CSO. First one always goes in the middle again. S on one side, O on the other, doesn't matter where. Put your dots on. Connect your unshared pairs. Okay, so again this is linear because I have 2 atoms connected and the center atom has no extra pairs. So I'm going to draw it in a nice neat line, so same shape as the other example, but here, let me get my dots on there. The difference is that the outer atom over here, the S, is not the same as the outer atom on the other end. So when the outer atoms are different, this molecule is polar. Alright, now that is also true for a trigonal planar molecule. In this, trigonal means 3, so you've got 3 atoms, but you have 0 unshared pairs. And so same rule, it's polar if the outer atoms are different. So same rule as linear. So BH3, 1 dot for each hydrogen, connect everything. So I've got 3 atoms and 0 unshared pairs, so trigonal planar looks like this in the shape of a letter Y. Okay. Then I look at the outside atoms. I have an H, an H, and H. If they're all the same, then you have a nonpolar molecule. Let's look at another possibility though. If I have BH2Cl, B in the center, 2 H's, and then put a Cl somewhere, 1 on each of the H's, connect your unshared pairs. Still trigonal planar because I have 3 extra atoms attached and no extra pairs on the center atom. So I still draw it in the same shape. It doesn't matter where this Cl goes. Don't forget to put the dots back on it. So here when I compare my outside atoms, I do have two H's, but this Cl is very different. And so because of that different outside atom, this is a polar molecule. The rule is exactly the same for tetrahedral. Tetrahedral, remember tetra means 4, so you've got 4 atoms connected and no extra pairs on the center atom. Again, polar if the outside atoms are different. So let's do 2 examples of that. So CH4, C in the center, H is on each side. You remember that this is organic. Carbon always forms 4 bonds. So 4 bonds, no extra dots. I draw it in a nice neat tetrahedral shape like a plus sign. Okay. Now look at your outside atoms. H, 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 H. If they are all the same, it is a nonpolar molecule. They're all being shared equally between the C's and H's. Now, if I look at CHBr3, start the same way. Carbon in the middle, 3 H's, and then I'll put the Br somewhere. Connect all your dots. So it's still tetrahedral. There's still 4 atoms there with no extra pairs on the center atom. So you still draw it in the same shape, tetrahedral. You put the extra dots back on your Br, but comparing the outside atoms here, H, 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 but when I have this one different one of Br, that is what makes my molecule polar. The Br pulls on the electrons in an unequal way. So those 3 shapes are the same. So if it is linear, trigonal planar, or tetrahedral, then you care that it's polar if the outside atoms are different. So those 3 all follow the same rule. Okay? Now let's talk about the other 2. We also have a molecule that is bent. You'll know that it's bent because the center atom will have 2 atoms and it will have 1 or 2 extra lone pairs. So that means you'll see some extra dots like that. That's what 1 or 2 pairs looks like. If you see that and you identify the molecule as bent, it's always polar and you do not have a choice. You can never have bent be nonpolar. Okay? So if I look at water, O in the center, H on each side, put in your dots. Remember to go in a circle all the way around. So here are my 2 atoms. There's one there, but I also have these extra pairs on the oxygen. That makes my molecule bent. So I have to draw it like this. Because I've identified my molecule as bent, it is automatically polar. I'm not going to ask myself any more questions. I'm done. Same rule applies to trigonal pyramidal molecules. Trigonal again means 3, but here you have 1 extra pair, so it'll look something like that. Trigonal pyramidal is also always polar. So if I draw NH3, oops, 1 extra dot there. Connect all my unshared electrons. So I've got 3 atoms here connected to my nitrogen in this 1 extra pair. That's the reason that I identify it as trigonal pyramidal. Once you decide on that shape, then you automatically know that your molecule is polar. That's all you have to know. So here's your step. First you're going to do a rough draft of your molecule. Next, you're going to decide on the correct shape. If you need help with that, go back to Unit 5. Okay? Then based on the shape, you can identify it as nonpolar or polar using the rules that we just said. So that's your steps and that's how you're going to figure this out. Okay? Lastly, who cares? Why are we bothering to learn about this? Okay? This actually happens a lot out in the real world and you didn't even notice it. Polarity determines solubility. Remember, solubility means what can dissolve. Okay? So, there are some things that dissolve with each other and some things that don't. So, for example, like dissolves like. What that means is I can put water and salt together, and salt dissolves in water, like the ocean, right? So, both of these are polar, water and salt. So, because like dissolves like, the salt will dissolve when you put it in the water. They are both polar molecules. Okay? Now, an example of something that doesn't dissolve is like water and oil. The reason why is water is polar and oil is nonpolar. They're not the same. That means that they will not dissolve, and so if you've ever tried that, you get kind of those layers, right? The oil and the water don't mix together, they stay separate. That is because of their polarity. Alright, now it's your turn to do some practice. Let me know if you have any questions.